At the GTC conference in March 2026, Jensen Huang stated, "The next decisive battlefield for AI infrastructure is not compute, not memory, but connectivity." In the following month, NVIDIA invested $6 billion in 3 optical technology companies. 2 years earlier, however, he had publicly described optical interconnects as too power-hungry. Behind this 180-degree shift lies an ironclad rule forced by the explosive growth of AI computing power. Copper cabling has reached its physical limits, and optical interconnects are not merely a better choice, they are the only way forward. Why is copper cable no longer sufficient? This is not an engineering problem, but a physical one. The physical limitations of copper cables can be summarized in 3 weaknesses: signal attenuation, crosstalk, and power consumption. Let's start with the issue of attenuation. Electrical signals constantly weaken during transmission. The longer the distance, the weaker the signal becomes. It is like running on a muddy road. The further you run, the more of a struggle it becomes. Crosstalk is also a silent killer for copper cables. When a large number of copper wires are packed closely together, electrical signals interfere with one another, much like a classroom where everyone is talking at once, making it impossible for anyone to hear clearly. Finally, there is the issue of power consumption. Some studies suggest that when transmission speed doubles, power consumption can increase by up to 4 times. In an era where a single GPU already consumes over 1,000 watts, no data center operator is willing to allocate a significant portion of its valuable power budget to copper cable transmission losses. In addition, copper cables present several unavoidable challenges. They are thicker and heavier than fiber optic cables, and the larger the AI cluster, the more difficult the cabling becomes. In the same amount of space, they can accommodate far fewer connections than fiber optic cables. Furthermore, large quantities of copper cables piled up in server racks can obstruct airflow, further increasing the cooling burden on the data center. Once the physical limits of copper cabling are understood, the positioning of optical interconnects takes on a completely different perspective. Optical interconnects are not a new technology. Fiber optic communication has long been used between data center racks. The advantages of optical interconnects can be summarized as fast, stable, and long distance. Light travels through glass fiber cores, immune to EML, and free from the crosstalk issues associated with copper cables. More importantly, it enables longer transmission distances and higher bandwidth ceilings. These characteristics allow AI clusters to continue scaling up. Precisely because copper cables have clear limits in distance and scalability, the industry is actively seeking alternatives, showing a shift from copper to optical technologies. We can put it in a more straightforward way. The larger the AI cluster, the less space there is for copper cabling. Ultimately, it gets squeezed into just the final few meters inside the rack. What truly powers large-scale GPU interconnection is the fiber optic network. When tens of thousands of GPUs have to work together like one unified brain, copper cables quickly become the bottleneck, and optical fiber becomes the nervous system of the entire AI computing world. Without it, even the most powerful GPUs are just isolated computing nodes. If you want to learn more about AI data center connectivity solutions, don't forget to like and subscribe to our channel. See you in the next video.